So we're now building up to the whole climax of this discussion, which was the ParallelFlowable class. So the other discussions we've had thus far about flowable was just kind of to set the stage for ParallelFlowable. And ParallelFlowable is important, of course, because that serves as the key starting point for programming assignment 4B. So you need to understand how ParallelFlowables work. So we'll talk about ParallelFlowable class and what it does. So if you recall assignment 4A and more generally our discussion about the RxJava'sflatMap concurrency idiom, you'll remember that it performs relatively well, but honestly it's a bit convoluted. And as you take a look here, you can see that it returns an observable that emits multiple big fraction objects by the flatMap concurrency idiom. This particular example does that, which we talked about earlier. And you can see how it goes ahead and will take each item that's emitted from this big fraction array, and then it takes that item and it multiplies it in a background pool, which in this case is the computation pool. And then it goes ahead and reduces the results. So that's what we get here with this particular piece of code. It works, it's relatively efficient, but it's an idiom. It's not really baked into the, well, it's an idiom, so it's supported, but it's not really clean. And that's particularly obvious when you take a look at the corresponding Java Parallel Streams implementation. So unlike this implementation, which is a bit convoluted, this says take the big fraction array, process it in parallel, multiply each item by some constant big fraction, and then reduce the results by adding everything together. So I think it's pretty clear, at least to me, that this code is more intuitive to read, because you can read it from sort of from top to bottom, than this code, which is just a little bit more complicated because you have to do all this extra stuff, and you have to remember the idiom works in a certain way, and so on and so forth. So what RxJava did to make parallel processing more like parallel streams, at least syntactically in terms of syntactic conciseness, they added a new class called ParallelFlowable, which is a subset of Flowable. It's kind of an extension of Flowable, but it doesn't have all the features, that provides a more concise means of processing multiple values in parallel. It's very similar to parallel streams in that it kind of looks like just a flow of operations from top to bottom. It avoids the convoluted syntax of the flatMap concurrency idiom. And it does this by providing yet another factory method operator called parallel, which converts a flowable into a ParallelFlowable. So if you have a flowable, like we see up here, and you say parallel, you can give it a count, or you can let it default to the number of cores, or something around the number of cores. And then what happens under the hood is you have these things called rails, the kind of the dark black arrows, 3 dark black arrows correspond to rails. And these operations are kind of run in they're kind of mapped in a round-robin-like fashion from the original stream into the ParallelFlowable, and then processed in parallel. So the elements that are provided from the original stream that started out this process are processed in parallel via the rails, these dark black arrows, in round-robin order. Just kind of throws them in there. So it's not a very sophisticated model. It doesn't support work stealing, for example, but it gets the job done. Well, I take it back. It could support work stealing. We'll talk about that in a second. By default, the number of rails is set to the number of available CPUs. And I should say cores, because it's really CPU cores, but you get the idea. So if you have 6 cores, you'll have six rails. You can change the setting by giving a value to the parallelism parameter, which is optional, passed to the parallel factory method operator in the Flowable class. Now, what's interesting about this is that ParallelFlowable only supports a subset of the flowable operators. So you don't have everything. You just have the main ones that work well on embarrassingly parallel problems. So you can see here we have map, filter, concat map, flat map, collect, reduce, all these kinds of things. Those are all supported, but some of the other stuff is not. So let's talk about some of the methods that are provided here. And one of them, this is actually not from the Flowable class. This is added here. The run-on operator, which specifies where each rail will observe its incoming elements. And so that's basically used to give a scheduler, and the scheduler that's given here does not do work stealing. So basically it just throws them in there and lets them run. And it returns a new ParallelFlowable instance, which you can then apply all these other operators to, but of course they're a subset of Flowable. Now, once you've reached a point where you've done all your parallel processing, and perhaps you want to use some of those other operators we talked about, you can go ahead and convert the ParallelFlowable back into a Flowable by using the sequential operator. And you can think of sequential as a bit like a join. It's kind of like a gang join or a group join. It joins everything together into one final result. So what it does is it merges the results, the values from each of these rails, in round-robin fashion and creates a new Flowable. So it returns just a good old Flowable sequence like we've seen before, and then you can do other stuff to that. So let's take a look at a very simple example. So this example will essentially convert an array into a Flowable. Then it'll turn the Flowable into a ParallelFlowable. It'll then map that ParallelFlowable to run on the computation thread pool. Then it goes ahead and uses, now we're running map to the computation thread pool in a ParallelFlowable. The map operator is called. That's going to multiply all these things together. Or sorry, it'll multiply each one by this big reduced fraction. And then we convert that back into a sequential result, to a sequential Flowable. And then we reduce all the results together by adding them. So we take all the elements in the stream and we add them together. And then the very final thing we do is we go ahead and print the results, display the results, if all goes well. Yes, sir? Oh, did it say that? It probably did. You're right. Thank you. That's a cut and paste there. So this should say, designate the computation scheduler that will multiply each image in parallel. Thank you for pointing that out. So that's the overview of the ParallelFlowable class. And that class is important because you're going to use it a bunch of places in assignment 4B in lieu of using the more convoluted flat map concurrency idiom.